Suppose you were given circle O, and I asked you to find the area of the region bounded by chord AB and arc AB. That region is shaded in the picture. How would you do it? Well, we'd need to give you the radius. So suppose I told you the radius is 10, and the chord AB is 10. How would you find the area of the shaded region? Please pause the video and see if you can figure it out, because that's the topic of today's video. The area of sectors, which we've already learned, and segments, which are going to be something new to us. So take a minute and see if you can solve for the area of the shaded region. All right, to find the shaded area, I subtracted the area of triangle AOB from sector AOB. Now, of course, since OB is a radius and AO is a radius, AO equals 10. So I can find the area of triangle AOB simply by using the formula side squared root 3 over 4. And I can find the area of sector AOB by multiplying 60 over 360 times 10 squared pi. Now, how did I know that angle AOB was 60? Well, of course it has to be, because this is an equilateral triangle. So, if that's a 60-degree angle, then AB is a 60-degree arc, and as you recall, the formula for the area of a sector is arc measure over 360 times pi r squared. All right, so that's going to simplify to 50 pi over 3 minus 25 root 3. Okay, Ramblers, let's get down into today's video. Take good notes, thanks for watching, and stay tuned. Hey Ramblers, this video covers chapter 11.6 in our textbook, and it deals with the area of circles, sectors, and segments. Now what's great about that is we've already covered the area of circles and sectors, but segments are something new, and something that the opener problem kind of alluded to. So we're going to define what a sector is, and we're going to review what the area formula for a circle is and what the area formula for a sector is. And then I'll wrap up with a couple of tutorials for the problems. Okay, once again, go slowly, rewind if you need to, pause often, and take good notes. Okay, thanks for watching. Okay, there's quite a bit of review in chapter 11.6, and it starts with the area of a circle. As you recall, and let's make sure it's in your notes, the area of a circle is pi r squared. Well, then they move into the area of a sector. Now you'll recall that a sector is a portion of a circle. So, for instance, sector QOP is part of circle O. And the fact that arc QP measures 60 degrees tells us that this is 60 3/60ths, or 1/6 of the entire area of the circle. So I'm going to take the measure of the arc divided by 360 times the area of the entire circle, and I'll get the area of the sector. Okay, notice over here that as I manipulate the measure of angle O, or angle QOP, it changes not just the arc QP, but it also changes the measure or the area of the sector. The area of the sector is dependent not only on the angle, the central angle, or the measure of the arc, but it's also dependent upon the size of the circle. You can see that as I increase the size of the circle, while the measure of the angle doesn't change much, certainly the area of the sector changes. Okay, so this is another formula that you'll want to make sure you have in your notes, so please pause the video and make sure it's there. What is going to come up a lot in this section is going to be the area of what's called a segment. So let's take a look at what a segment is. A segment is a region that is bounded by a chord and the arc. So imagine the sector that we just talked about, sector QOP, which would be bounded by this arc and the two radii, is a piece of pizza. The segment is kind of like the crust on the pizza. So in order to find its area, we find the area of the sector, and then take away the area of this triangle formed by the chords and the two radii. So that gives us, it's not really a formula as much as a method for finding the area of a segment. The area of a segment is equal to the area of the sector, QOP, subtracted by the area of the chord radii triangle, QOP. Okay, so make sure those are in your notes. We've got 3 formulas in total: the area of a circle, the area of a sector, and then the area of a segment. Make sure these are in your notes. Thanks for watching, and I hope this helped. We're going to wrap up with a couple of tutorials from the exercises. Thanks, Ramblers. Okay, number 11 on page 540 asks us for the area of each segment. Now, a segment, you recall, is a shaded region. It's between a chord and an arc. So in 11a, we're going to find the area of the sector minus the area of the triangle. The area of the triangle is going to be, the area of the sector will be 90 over 360 times 8 squared pi, minus the triangle, which is a right triangle, so that's just going to be 1/2 leg times leg. That gives us a final answer of 16 pi minus 32. Now in part B, we have the sector filled in, but they didn't really indicate what the triangle is. So I'm going to include a radius from the end of the chord to the center, and you can see that if it's a 60-degree angle making up the arc, then it's a 60-degree central angle, which makes this a regular triangle. So the chord is 8, and both of the radii will be 8. That's going to help me to find out the area of that triangle. So to find the area of the segment, I'm going to take the area of the sector minus the area of the triangle. The area of the sector, of course, will be 60 over 360 times 8 squared pi minus the area of the triangle. And I'm going to use the formula we developed for the area of a regular triangle, which is 8 squared root 3 over 4. If I simplify this, I get 32 pi over 3 minus 16 root 3. Okay, let's take a look at one more, or I should say a couple more problems. Number 14. 14C and D kind of give you a look at how to do all of 14. And you can see that in part C, we're trying to find the shaded region, which is really just a square minus the 4 sectors, or 4 quarter circles. Well, we know that the square is going to be 10 squared. And the 4 quarter circles could be found by multiplying 4 times each one of these 90-degree angles. So you get 90 over 360 times, now be careful, the radius of each circle is 5, so it's going to be 5 squared pi. The final answer will be 100 minus 25 pi. Now let's take a look at part D. The area of this triangle is just going to be 10 squared root 3 over 4, because that's a regular triangle. And then we're going to subtract the 3 sectors. 3 times 60 over 360 times, again, 5 squared, because 5 is the radius of those circles, so the area of them will be 5 squared pi. If we simplify that, we get 25 root 3 minus 25 pi over 2. Okay, Ramblers, that should give you an idea how to handle the homework. Thanks for watching.